Imagine you are preparing your data for a powerful machine learning model. You want all your features to contribute equally and perform their best. Scaling your data is a crucial step in this process. While min-max scaling seems like a simple and effective choice, it is important to understand its limitations. The primary drawbacks of min-max scaling are its extreme sensitivity to outliers and its inability to naturally handle new data points that fall outside the original range used for transformation. These characteristics can significantly impact your model's performance and generalization ability. Min-max scaling, also known as normalization, works by transforming features to a specific range, typically between 0 and 1. It achieves this by subtracting the minimum value of a feature from each data point, and then dividing by the range, which is the difference between the maximum and minimum values. Because the scaling relies entirely on these extreme minimum and maximum values, even a single outlier can drastically distort the entire scaled distribution. If your data contains a few unusually high or low values, the majority of your data points might get compressed into a very narrow segment of the new 0 to 1 range, losing much of their distinction. Furthermore, when you deploy your model with new, unseen data, a new data point might have a value lower than your training minimum or higher than your training maximum. When you apply the original scaling formula, this new data point will be scaled to a value outside the desired 0 to 1 range, which can cause issues for models expecting inputs within that specific boundary. To mitigate these issues, always conduct thorough exploratory data analysis to identify and address outliers before applying min-max scaling. If outliers are present and cannot be removed or transformed, consider alternative scaling methods. For example, standardization, which is also known as z-score normalization, scales data to have a mean of 0 and a standard deviation of 1, making it less susceptible to individual extreme values. Another option is robust scaling, which uses the median and interquartile range, offering even greater resilience to outliers. A critical concept related to these drawbacks is data leakage. If you calculate the minimum and maximum values from your entire dataset before splitting it into training and testing sets, you might inadvertently leak information from your test set into your training process. Instead, you should always fit your scaler, whether min-max or otherwise, only on your training data. Then, apply that fitted scaler to both your training and test sets to maintain the integrity of your model evaluation. This ensures your evaluation accurately reflects the model's performance on truly unseen data. Understanding that min-max scaling is sensitive to outliers and new out-of-range data points is crucial for building robust machine learning models. By carefully inspecting your data and choosing the appropriate scaling method, or addressing outliers, you can ensure your features are optimally prepared, leading to more reliable and accurate predictions from your models.